As we talked about in class, you're going to have to factor these things. So for instance, this n squared minus 5n plus 6 can be broken apart into n minus 3 and n minus 2. Now, as we said before, that's equal to 0, and we would have to set the individual factors equal to 0. Sorry, that's bad looking 0. N minus 2 equals 0. So when we solve, we end up with 2 and we end up with 3. Now, there was no way for me to just add a number to the other side and take a square root. That did work out nicely in the first example. Some of you did make that observation. Instead of factoring, you could have done that. But noticeably missing was a 0x, was any kind of linear term. I should say that. I shouldn't say 0x because that's what it is. There was no linear term up there, and that linear term stops you from doing that little square root trick, unless you have a perfect square. So factoring this, what multiplies together to give you 9, but adds up to negative 6? Of course, they both have to be negative in order to add up to a negative number, but multiply to a positive, and hopefully you know that it's 3 and 3. Now, if that's equal to 0, the question becomes, do I have to write down 3 more than one time? The answer is no. The only value that is a solution is 3 to that question. So, we will talk about that more when we get to polynomials. Continuing down this, so factoring, this has got a greatest common factor in it. That greatest common factor is plain old x. And if we factor this, we could bring out the x and make x minus 22 be left over. There's no way to factor that farther. So in this particular case, we can set the factors equal to 0 and solve. Well, look, the first one's already solved. I mean, there's nothing more you can do with that. 0 is one of the answers to the question. The other one is just plain old 22. Okay, so in question 5, which is kind of similar to question 4, we're going to bring that over to the other side first. In other words, in order to do these little, to do the factoring questions, you have to have it set equal to 0. So far, the questions I've been asking you have been set equal to 0. We need to take that GCF out. That GCF out in this case is 4x. If we pull out that 4x, in other words, we go through and we divide everything by 4x to find out what's left over, we end up with that right there, 4x times x minus 4. So, set the factors equal to 0, 4x equals 0, x minus 4 equals 0. Yes, you would divide by 4 on this one right here, and guess what? You still end up with 0. On this one right here, you would add 4 to both sides and get positive 4. So the only numbers in the universe which would make this a true statement are 0 and 4. 0 isn't always an answer, as you've seen in other questions, but does show up. Now, we're not going to use a table for this, okay? So, you can cross that off. We're going to factor. Alright, so just get it in your head that we're going to factor these. So, you work on doing your best to factor what's given to you. Think about numbers that multiply together to give you 32, but add up to negative 12. Well, it's definitely not 32 and 1. And it's not 16 and 2. But it is 8 and 4. So, x minus 8. X minus 4. Set the factors equal to 0. And out of this one, hopefully what you're starting to see is that it's not hard to see that you are getting. A lot of kids start saying, oh, that's just the opposite. Well, if you get more complicated factors, you better be careful. But right now. Those are simple factors, and yes, you do get the opposite. So we're going to be factoring these. Okay. Question 7, a smoke jumper jumps from an airplane that is 1,800 feet above the ground. So these are firefighters that are jumping into forest fires to prevent them from spreading. The function that you're given gives the jumper's height in feet during the free fall at t seconds. Now, if you pay attention to what kind of parabola we're talking about, we're starting out at 1,800. And pretty much, I think this is a bad picture. Pretty much you're starting out and you're just doing this, okay? Unless you can jump up in the air, but this formula does not show that you're jumping up in the air. This formula says you're just falling out of the plane, okay? Now, if we want to know when the parachute opens at 1,000 feet, then that's what our H value is going to be, 1,000 feet. Now, this is not a factoring question. Okay? It is a solving question, but it is not a factoring question. We are going to push that 1,800 to the other side. And if I subtract the 1,800 to the other side, I end up with negative 800 equals negative 16 t squared. So when you divide by negative 16 t squared equals some value, I think. Let me just double check. Maybe I'm wrong. I'm thinking 800 16 is 50. Okay, that's t squared though. The other way, the way to get rid of the square is to take the square root, and that's going to give me a value that is approximately equal to. It's got to be a little bit more than 7, right? Square root of 50 is 7.07. Now that's seconds. Alright, 7.07. I'm probably going to only ask you one of these questions. I won't make you do the other one. There's no point to that. Part C, though, says, what's a reasonable domain for the function? Okay, so if you look at my graph, along the x-axis, I have time, and along the y-axis, I have height. Now, what kind of domain? Domain goes with x's. Okay? Domain goes with x's, which in this case is time. Now, don't get distracted with that right there. So we are talking about time. Which of those sets of numbers? Well, can't be negative numbers. That just eliminated 3 options since you can't have negative time. We're not going back in the past. Okay? 1,800 seconds. I don't think you're going to be in the air for 1,800 seconds. So I think this is a reasonable amount of time to be free fall. In fact, we know you're going to get to 1,000 feet after 7.07 seconds. It'll take you about 10 seconds to go all the rest of the way. Okay, you must be picking up speed. What's a reasonable range? In other words, range would be your y values. Why is it not doing? Come on. So your y values in this case, well, you can't have negative height. Folks, we're not driving this. This person is not being driven into the ground. That would not be fun. But we're definitely more than 10 feet off the ground, so it makes more sense that 0 to 1,800 would be your possible heights. Okay, question 8. Period of the pendulum is the time the pendulum takes to swing back and forth. The function L equals 0.81 t squared relates the length in feet of a pendulum the time t seconds that it takes to swing back and forth. A conventional center has a detention center is a pendulum that is 90 feet long. Okay, so that's got to be my L. And they're asking me to solve that to 2 decimal places. You know what, I'm not going to argue with you there. But we would need to divide by the 0.81. Okay, so 90 divided by 0.81 gives me 111.1 repeating equals t squared. And in order to get t by itself, we have to do the same thing we did before, and that is to take a square root. So if I go to my calculator and I do the square root, I get 10.5. Approximately 10.5 seconds. Is that right? It's a 90-foot pendulum. It's going to take 10.5 seconds. It takes to swing back and forth. Okay, so one swing back, one swing. So that's quite a large amount of time here. I think I'm going to stop this video and have you work on those 8 questions. Okay, so if you've watched the video and taken the notes, then shift over to your worksheet and get those 8 questions done. Now, if you want to go forward and do 9 and 10, well, why don't you just wait on those, okay? Get 1 through 8. Whoops. Just get 1 through 8 on the on your packet completed. Okay, so go to the practice. I should say go to the practice page, which is the next one. There should be a practice page which has similar questions, and just go 1 through 8, and make sure you get those done by the end of the period. Okay, and I'll look at those next time.